So so in general, if there are any spikes in a particular region, for example, it will be very clearly understood by, for example, if one of these values is slightly high or combination of values are slightly high due to noise or something, for example. So you take one portion of image which has some 3 pixels on this side, 3 pixels on that. There are 9 pixels, for example. 3 into 3 is going to be 9. So there's 9 pixels. So you're taking an average of 9 values of the image pixel. Suddenly, if there is a image, there's a pixel value whose intensity is very large. That's supposed to be noisy pixel. So you will understand that by taking an average and comparing with the average of other blocks, you will see a block which has more average brightness will be possibly containing one or more noisy pixels. So some of those informations are very useful. So and kind of an image which probably has image histogram tells you about the nature of the image that you have, whether the image is fully exposed, underexposed or overexposed. Now, overexposed is the region something like this. Now you have more pixels or in the white region, right? This is the highest value of the image intensity, lowest value of the image intensity. So it is has not many pixels in the lower range. So now this is what is called as a properly exposed. For example, it has the range of pixel values in the middle. So when you have some of these ideas of histogram distribution, right, will tell you whether it is overexposed or underexposed. So you can see whether it is contrast or low contrast images. So look at the histograms of low contrast and high contrast images. So the image with normal contrast, we showed this image earlier to see how we can develop a given image like this into an image by doing some image manipulation, so pixel manipulation. So you can improve the contrast. So so there's an equation to improve the contrast of the image using Michelson equation. So change in luminance divided by average luminance. So if you can do this change in luminance by average luminance, you get the contrast equation. So these equations work well for simple images with 2 luminances. Does not work well for complex images. So complex image, I mean the one you saw earlier with multiple people present in an image. Complex image with multiple objects that are being there. So when you have such kind of large details in an image, we call it as a complex image. So again, the dynamic range of an image, right? Pixel distribution will tell you dynamic range, number of distinct pixels that is seen in image, for example. So this is a high dynamic range, meaning that all pixels are basically available in this. Here only some distinct pixels are there, only 64 intensities. Only 6 intensity values are present in the image. So for example, either you see this image, this intensity value, or you see this intensity value or this intensity value. So all pixels, the number of pixels though are same, but however, of course, these heights keep varying. The number, they are not of uniform height. That is why. So, look at this region, all captured in, for example, in this particular value or something. So dark value here that may be captured by some of those. So all of them are, they're only 5-6 intensity values. Okay. So now when you want to have high dynamic range imaging, you should have very bright and very dark parts of the image. So it should have many distinct pixels that you see here. So all pixels are equal, are available. So of course, when you do high dynamic range image, then you should be able to put a lot of bits to represent pixels. Okay. So to probably find or obtain a high dynamic range image, you have to do some image processing. So you capture multiple images at different exposure, combine all these images together, then you get what is called a high dynamic range imaging. So you can also look at certain defects through histograms. So histograms implementation of histograms, or for example, finding or drawing or plotting or all these histograms is a very important way. For example, don't use the direct MATLAB command for this. Maybe you will be able to analyze, able to pick up, for example, from 0 to 255 and do some kind of binning operation, which probably we'll see it later. Try to collect pixels corresponding to certain intensities, for example 0 to 10 in one particular bin, and find out the number. So put that value there, and then between 0 to 10 range you get this height of the histogram. Again 10 to 20 you will have one more bin. You collect a number of pixels on this, then you will have another. So you keep constructing like this, then you will get a histogram like this. So I mean, by looking at these histograms, you'll be able to see certain defects in the histogram. So there are saturations. Saturation means you get more intensities on this side. For example, this shows you there's saturation in the intensity values. Okay, so results in spikes at the ends of the histogram. So some of these information that you will be able to understand from looking at the histogram. So this is image defects, right?